Good afternoon, everyone. My name is Heryadi, and today I'll be discussing about physics, about optical devices mirrors. The first one is plane mirror. It's a flat, smooth surface which allows a regular reflection of light. There are 6 characteristics of the image formed by a plane mirror. The first one is same size, second same distance, third one same appearance, the fourth is laterally inverse, the fifth one is erect or upright, the sixth one is virtual. There are 2 types of image. The first one is real image. Real image is a type image which is formed in front of the mirror and can be projected on a screen. While virtual image is a type of image which is formed behind the mirror and cannot be projected on a screen. The second optical device is curved mirror. Curved mirror is a curved smooth surface which reflects light irregularly. There are 2 classifications of curved mirror. A. According to the reflecting surface. First one is concave mirror, or it's called converging mirror. Concave mirror is the reflecting surface is inside the sphere. It's used to enlarge the image. For example, dentist mirror and magnifying glass. Example of concave mirror is object at between curve of curvature and focus. We put the real object between curvature and focus. Then we pull a line from real object to the mirror and reflect it to the focus Then we get another line pulled from the real object through the mirror while passing through the focal and reflect it towards me. Then we get the real image, real, bigger, and inverted. The second one is convex mirror or diverging mirror. Convex mirror is the reflecting surface is outside the sphere. It's used to reduce the size of the image. Example, mirror at the store and sidecar mirror. Example of convex mirror. While object at F, the variable t is the real object. So we pull a line from the real object through the mirror through the curvature passing the mirror, while another line we pull from the real object through the mirror bounced upwards. The line that goes upward we extend so that the line passing through the focus. Then we get the real image is virtual, smaller, and erect. Two classification of curved mirror. B according to shape. The first one is spherical mirror. Spherical mirror consists of a reflecting surface whose curvature is a perfect sphere or circle. While the other one is parabolic mirror. Parabolic mirror consists of a reflecting surface whose curvature is a section of a parabola. Then ray diagram. Ray diagram is used to locate the image formed by mirror and lenses. That is the picture of ray diagram with the parts. The parts of ray diagram have C, center of curvature, F, focus, focal length between focus and vertex, and the middle line is principal axis. Mirror equation. There are 5 mirror equations. First one is 1 per F equals to 1 per dO plus 1 per dI. Second, Si per So is equal to negative Di per Do. Third one, M is equal to negative Di per Do. The fourth one, M is equal to Si per So. The fifth one, A is equal to 4 square root of LF. The definition, F is focal length, Do is distance of the object, Di is distance of the image, Si is size of the image, So is size of the object, A is aperture, L is the length from the point of intersection of the aperture and the principal axis to the vertex. This is the table between concave mirror and convex mirror. When the focus is positive at concave mirror, when the F is positive, it includes the concave mirror, while the F is negative, it includes the convex mirror. When DO, distance of the object, is positive, it can be concave mirror or convex mirror. While distance of the image is positive in concave mirror, distance of the image when positive is real, while negative is virtual. Distance Di in convex is always negative. Then while So in concave mirror and convex mirror is always positive. Si in concave mirror, when positive, it is erect, while negative, it's inverted. While Si in convex mirror is always positive. Examples. A 3 cm object is placed 5 cm from a curved mirror. If virtual image is formed 8 cm from the mirror, A. What is the focal length? B. What type of mirror is used? C. How far is the image is from the mirror? D. How tall is the image? E. What is the position of image? Given So size of the object is 3 cm, Do distance of the object is 5 cm, Di distance of the image is negative 8 cm, L is 2 cm. Distance of the image is negative 8 cm is because in there is written virtual image, so it's negative. A. To find focal length, we use the equation 1 per F is equal to 1 per Do plus 1 per Di. Then we substitute the number 1 per F is equal to 1 per 5 plus 1 per negative 8. Then 1 per F is equal to 1 per 5 minus 1 per 8. We multiply the denominator to find the common factor. 1 per F is equal to 8 times 5 is 40. 40 divided by 5 times 1 is equal to 8. Minus 40 divided by 8 times 1 is equal to 5. So 8 minus 5 divided by 40 is equal to 3 per 40. Then 1 per F is equal to 3 per 40. We cross multiply. 3F is equal to 40. F is equal to 40 divided by 3 is equal to 13.33 centimeter. Then we round off to 13 centimeter because all of the number is whole number using significant figures. B is concave mirror because the focal length is positive. C. Distance of the image is negative 8 cm because it's virtual. D. To find size of the image, we use the equation Si per So is equal to negative Di per Do. Then we substitute the number Si per 3 is equal to negative times negative 8 divided by 5. We cross multiply, 5 Si is equal to 24. Si is equal to 24 divided by 5 is equal to 4.8 centimeter. We round off to 5 centimeter. E, upright because size of the image is positive. F, to find the aperture, we use the equation A is equal to 4 square root of LF. Then we substitute the number. A is equal to 4 times square root of 2 times 13. A is equal to 4 square root of 26. It's equal to 20 centimeter. Second example. A 2.50 centimeter object is placed 5 centimeter in front of a convex mirror, whose aperture is 19.6 centimeter. With an intersection 3.00 centimeter from the mirror. A, what is the focal length of the mirror? B, how far is the image from the mirror? C, what type of image is formed? D, what is the size of the image? E, what is the position of the image? Given size of the object is 2.50 centimeter, distance of the object is 5 centimeter, aperture 19.6 centimeter, the length negative 3.00 centimeter. The length is negative because it's convex mirror. A, to find the focal length, we use the equation of A equal to 4 square root of LF. We substitute the number. 19.6 is equal to 4 square root of negative 3F. Then we square root both sides of the equation so that the square root can be discarded. 19.6 square equal to 16 times negative 3F. Then 384.16 is equal to negative 48F. F is equal to 384.16 divided by negative 48. It's equal to negative 8 centimeter. B, to find distance of the image, we use the equation 1 per F is equal to 1 per DO plus 1 per DI. We transpose the 1 per DO to the left side so that we can find the distance of the image. 1 per DI is equal to 1 per F minus 1 per DO. Substitute the number. 1 per DI is equal to 1 per negative 8 minus 1 per 5. Then we multiply the denominators to get the common factor. 5 times 8 is equal to 40. And 40 divided by negative 8 times 1 is equal to negative 5. Minus 40 divided by 5 times 1 is equal to 8. So negative 5 minus 8 divided by 40 is equal to negative 13 per 40. 1 per di is equal to negative 13 per 40. We cross multiply. Negative 13 di is equal to 40. Di is equal to 40 divided by negative 13 is equal to negative 3.08 centimeter. C, it's virtual because the distance of the image is negative. D, to find the size of the image, we use the equation SI per SO is equal to negative DI per DO. We substitute the number. SI per 2.50 is equal to negative times negative 3.08 per 5. We cross multiply 5 SI is equal to 7.7. SI is equal to 7.7 divided by 5 is equal to 1.54 centimeter. E is upright because the size of the image is positive. Thank you for watching and listening. I hope you understand what I'm explaining in this PowerPoint, and thank you.